we'll get through it. I just, you might see a little bit of redundancy in the stuff that I say today as we kind of go into our lab time together, because some of the stuff is just kind of better taught hands-on, but that's all right. So as far as where we're at, in our first unit, we talked about the structure of nerves in the beginning of the unit. And then we looked at the cranial nerves. We looked at those nerves that originate on the brain and the brain stem, all right? We saw that there are 12 pairs of cranial nerves, and we learned a little bit about what some of those cranial nerves do. And we went so far as to look at a couple of organs that are attached to those cranial nerves, right? We looked at the eye, which is attached to the optic nerve, and we looked at the ear, which is attached to the vestibulocochlear nerve. So, to kind of complete our tour of the peripheral nervous system, we need to look at the spinal nerves. And the spinal nerves, as the name implies, originate on the spinal cord. So let's go ahead and kind of take a look at the anatomy of a spinal nerve here to sort of review. Let me actually mute this. Let me do this. Here we go. Let's spend a minute on the board. So our spinal cord is this structure kind of right here. Right. It's got this bit of gray matter in it that looks kind of like this. It should look familiar to you at this point. And art isn't always the best, but I think you guys probably get the drift, right? So we've got this structure that looks kind of like this as our spinal cord. That spinal cord has two roots that are associated with it. And we learned about those in 50A. We sort of reviewed them last time. This is going to be our dorsal side over here. This is dorsal right here. This is going to be ventral down here. So that makes this one our dorsal root and this one our ventral root. We remember that the dorsal root has something associated with it. It has a cluster of cell bodies called a ganglion associated with it. So we see something that sort of looks like that. And then our ventral root does not have the same structure. So we end up with a situation that kind of looks like this. And then if we wanted to put some neurons in there, we know that our dorsal root has what kind of neurons in them? From a functional point of view, in here in the dorsal root, in the dorsal side of the spinal cord, would we find sensory or would we find motor neurons? So there are sensory neurons, right? And what structural class do those sensory neurons belong to? Are they unipolar, bipolar, multipolar? Huh? Oh, all right. So think about the structure here, right? What's inside of this? What's inside of our dorsal root ganglion? Yeah. So the cell. What part of the cell?
Cell bodies.
Cell bodies, right? So we got cell bodies in here, right? We'll just go ahead and do it this way. There's our little nucleus. So now, what kind of a neuron is going to fit the shape of what we've got right here? Unipolar, right? Yeah, unipolar neurons. So those sensory neurons are going to be unipolar neurons, and they're going to be kind of like this, right? So that sensory information is coming into the dorsal side of our spinal cord. Spinal cord is processing that information, probably sending it up to the brain. Only in a couple of instances does it process it itself. So we're going to have interneurons and such in there. But then we're going to have motor neurons that are leaving via the ventral root. Where are the cell bodies for those motor neurons found? In the spinal cord, right? Yeah. So what kind of a neuron would fit this? Multipolar, right? You guys aren't out of the woods on that. You can't forget that yet, right? Unfortunately, we can't quite forget that yet. We're not quite there. Give me 3 or 4 more weeks and you can forget it if you wish. But for right now, it's got to stick in your head. because we're going to be doing a lot of this. And we're going to add to it, too. We haven't even seen the whole picture yet. Okay, so we have a situation that looks like this, right? And if we were to track our flow of information, the information, that sensory information, would be coming in this direction like this, right? So this is sensory or afferent. And then this would be our outgoing motor or efferent pathway. Okay. And then, of course, I'm just going to go ahead and put a big integration right here because we know that that's what's happening, because the spinal cord is part of the CNS, and that's going to be our integrating center, right? So we have a situation that looks like this. Okay. What we're focused on now is not so much what's happening here. We've covered that already between 50A and a little bit in this class, but we're interested in what's happening out here. And specifically, what I'm interested in is I'm interested in this structure right here. This is that spinal nerve that we were talking about, right? So this is our spinal nerve. In lab today, I'll show you these spinal nerves on the model of the vertebral column that we have in lab. You can see them coming out between every two vertebrae, right? There's going to be a spinal nerve coming out. Obviously, there's another one on that side. They're paired, but we're not going to worry about that side quite as much right now. So this is a spinal nerve, okay? That spinal nerve, as we established in our first unit, has both sensory and motor neurons that are bundled into it. So what is the function of that spinal nerve? It's mixed, right? What is the function of the next spinal nerve in line? Mixed. What is the function of the next spinal nerve in line? Mixed. Okay, so on an exam, I'm going to point at a spinal nerve. I'm going to ask you to identify it. I'm going to talk in just a minute about how to identify it. But I'm going to ask you how to identify it. I'm going to say, what's the function of this structure? What are you going to tell me? It's mixed. So say it louder. What are you going to tell me? It's mixed, right? Okay. I'll be pointing at one of the ones in the thoracic region, and somebody's going to say, it innervates the arm. It doesn't innervate the arm. It's mixed. That is its function. It is mixed. Okay? So, okay. So they all are mixed in function. That makes life easier, right? With our cranial nerves, we had to remember our mnemonic, right? Remember, some say "Merry money," right? We had to remember our mnemonic to help us with that. But for our spinal nerves, all of them are mixed in terms of their function. So that makes life a little bit easier, okay? Naming them, as it turns out, is a little bit easier as well, right? So how did you name the vertebrae in 50A? How to name each individual vertebrae in 50A? How did we do that? Right, so what we had to do is we had to divide them into the region that they belong to, right? And then we also had a number associated with them, right? Well, it turns out that our spinal nerves are identified in the same way. Okay, they're identified by the region that they belong to, as well as their number. Okay, so as far as the region goes, what's our first region? As we leave the skull and we go into the spinal cord and the vertebral column, what's our first region that we're looking at? Cervical. Cervical, right? Yeah, our cervical region is here. Next, we have thoracic, right? After that, lumbar. And after that, sacral, right? And then we even have coccygeal as well. I'm not so worried about those. But we have a coccygeal region as well, right? So we have our regions that we were able in 50A to divide our vertebral column into. Okay? We do the same thing with our spinal nerves. We can look at our spinal nerves in the cervical region. We can look at them in the thoracic region, the lumbar, sacral regions. There's a couple of coccygeal spinal nerves that we pay close attention to. But, cervical spinal nerves, okay? You have 7 cervical vertebrae, okay? The numbers are for the most part the same, and in lab I'll kind of explain why this is the way that it is. But as far as cervical spinal nerves go, you have 8 pairs of cervical spinal nerves. You have 7 vertebrae, you have 8 pairs of cervical spinal nerves. Okay. The thoracic stays the same at 12, the lumbar stays the same as 5, and then the sacral, we also see that there are 5 pairs of spinal nerves, right? So these are our spinal nerves. Being in 50A, you probably learned to remember this using something like you get up at 7, you have lunch at noon, you have dinner at 5, or something along those lines. This is kind of like the weekend, right? You get to sleep in a little bit now until 8, right? But that's really the only difference. You still have to have lunch at 12 and dinner at 5. It's the old person meal schedule. All right. So pretty easy to identify them. Again, in lab, what I'll do is I'll show you guys a vertebral column that we have, and I'll show you how to count those out. Probably something you guys are all really familiar with at this point, but I'll show you anyway. To be honest, this is kind of one of the things that I think people, it's easy, but I think sometimes we get complacent with easy things. And so sometimes people make mistakes. Most of the mistakes on lab exams that I see when I ask people to identify a particular spinal nerve on that model that we have is they're usually off by 1 number, right? You know, it's just a matter of just slowing down, counting very carefully, and not being in a hurry. And that's one of the things that I think we all could probably work on in some aspect of our life. But nevertheless, we have these spinal nerves. Okay, so again, pretty easy to name them. Okay, so what we do is we just go cervical spinal nerve 4. Okay, thoracic spinal nerve 2, lumbar spinal nerve 1, and so on and so forth. So they're very easy to name, and then of course their function is all what? Mixed. Mixed. That's right. All right, cool beans. You guys got it. Okay. Any questions so far? I like spinal nerves. They're not too bad. Yeah. What's that? What's my number say? 20, 30. There's 1 coccygeal. Oh. Yeah. I don't pay that close of attention to it, but it is there, and I guess it is important, so I'll put a number there. Okay. Okay, so what we want to do now is we want to take a look at where that spinal nerve goes, right? We took a look at where at least a couple of our cranial nerves went. We got a pretty decent look, I guess, at all of them, but then we looked at a couple in depth. But we want to look at where our spinal nerves go. And the reality is that the spinal nerves themselves are really quite short. What you're going to see on the model that I'm going to start with in lab today is the spinal nerve is just this little nub coming off of the spinal cord. And that's really about all that it amounts to. What it's going to do is it's going to start to branch almost immediately. And the fibers that are in it are going to start to branch in different directions. Now, those branches ultimately are going to start to make up some of the nerves that you guys know the names of, right? I'd imagine that you know at least 1 or 2 names of nerves that run through your arms and your legs. You know, one of the ones that we often have problems with is one that runs down the back of our thigh. It's a fairly big one. And if you have a job where you might be forced to sit a lot, sometimes you can apply pressure to it and it can become inflamed. What nerve is that one? It's your sciatic nerve, right? That really big one that runs down the back of your thigh is your sciatic nerve. So that sciatic nerve comes from these these spinal nerves. Okay. So let's go ahead and take a look at what happens as this guy sort of goes on and it starts to branch. So again, the spinal nerve itself is relatively short, and then we see that it starts to branch again. What it does is it branches into what we call rami. Okay, so just like we have a dorsal root and a ventral root, we're going to have a dorsal ramus. We're going to have a dorsal ramus, and we're going to have a, whoops, that's a terrible arrow. We're going to have a ventral ramus. So we have a dorsal and a ventral ramus. And the fibers that are in that nerve are going to go kind of split, and some of them are going to go into the dorsal ramus, some of them are going to go into the ventral ramus. Because remember, it's not just two fibers that we're looking at here. There are hundreds, if not thousands, of fibers in there, right? So some of them are going to go into our dorsal ramus, some of them into our ventral ramus. And the rami, just like the spinal nerve, are, I guess, mixed in terms of their function. So they're going to contain both sensory and motor fibers here, as well as sensory and motor fibers here, right? So it's not like the sensory and motor fibers are separating or anything like that. They're both going in different ways. This is just sort of a way to distribute them to different parts of the body, okay? Okay, so let's go ahead and take a look at where each one of these goes. And I have a couple of pictures in my notes to show you here in just a couple of minutes, but rather than put the screen up and down a whole bunch of times, I'll just go ahead and talk for a minute and then we'll put the screen down. So the dorsal ramus, the nerve fibers that are in there, the neuronal fibers that are in the dorsal ramus, by and large go to innervate the dorsal body wall, okay? So whether we're talking about the cervical region, the thoracic region, the lumbar region, or the sacral region, by and large, those fibers go and innervate the dorsal body wall. So a lot of the muscles in the back are innervated by nerve fibers from the dorsal ramus, things like that. So by and large, the dorsal ramus works to innervate the dorsal body wall. And we'll just go ahead and here and say, for example, back muscles. Etc. Okay? So back muscles and things like that is kind of what we're working on innervating. Okay? So the dorsal ramus is pretty straightforward, okay, in terms of what it's innervating and kind of where it's going. Okay. The ventral ramus, the story gets a little bit muddier, okay, and it really depends on what region we're in. Okay, it really depends on what region we're in, what the ventral ramus, what those nerve fibers in the ventral rami end up doing, and where they end up going. All right. I think the thoracic is probably the easiest place for us to start. All right. In the thoracic region, the ventral rami really kind of do the same thing that the dorsal rami do. What they do is they just innervate the ventral body wall. Okay, so in our thoracic region, those nerve fibers from those ventral rami come out here and they innervate our ventral body wall. Now, one of the hallmarks, of course, of your ventral body wall in your thoracic cavity is what? What do you find on your body wall in your thoracic region? You do find a diaphragm, but even above that, like, what are these? What am I hitting right now? I'm hitting my ribs, right? Your rib cage is a really important hallmark of your thoracic body wall, right? What the nerve fibers from the ventral ramus do is they tend to innervate our rib cage, and specifically those nerve fibers go on to form what we call intercostal nerves. Okay, so in the ventral ramus, in the thoracic region, thoracic region, they form the intercostal nerves. We'll talk about the diaphragm more in just a couple minutes. Innervate the body wall and become the intercostal nerves. Okay? So in the thoracic region, those ventral rami innervate the body wall and become the intercostal nerves. All of the other regions, in the cervical region, in the lumbar region, and in the sacral region, those ventral rami form what we call plexuses. Okay, so we want to spend most of our time today in lab, as well as our time on Thursday in lab, looking at the anatomy of these plexuses. So in the thoracic region, they form the intercostal nerves. But in the cervical and lumbosacral regions, in the lumbosacral regions, we see the formation of plexuses. See the formation of plexuses. Okay. So as far as a plexus goes, I suppose we should first sort of identify what it is. A plexus is what happens when the nerve fibers in the ventral rami in these regions kind of join with the nerve fibers from other ventral rami, and it creates sort of a network of nerve fibers. Okay, and some of these plexuses look like nets. Okay, we'll have some pictures of them to show you in just a couple of minutes, but they kind of look like nets, and the nerves that result from that are the ones that we give names to, like the sciatic nerve. Okay, so we're going to take a look at some of those, but basically it's just sort of a net-like structure that's formed when we see that the nerve fibers are joining and separating in different ways. Again, I'll have some diagrams of this for you guys here in just a couple of minutes. So there are four main plexuses that we're interested in. Okay, there's four plexuses that we're interested in. There's the cervical plexus, which makes sense. I bet you're going to find it in the cervical region. The lower part of the cervical region creates a second plexus as well, called the brachial plexus. Okay, that's where we're going to spend most of our time today, is looking at the brachial plexus. What does brachial mean? Arm, right? So the brachial plexus innervates your shoulder and your arm, right? We're going to take a look at it today. We have the lumbar plexus, and we have the sacral plexus. Oftentimes we'll combine these two into what we call the lumbosacral plexus. Okay, combine them into the sacral plexus. When I use that terminology, just know that I'm combining the two into one. Let me see here. These plexuses can get a little bit on the complex side. This one isn't in my notes, but I'm going to show it to you anyway, and then I'll show you something that's significantly more simplified. So the cervical plexus looks a little bit like this. I'm going to put down the screen really quickly. I'm going to show you this. You're not responsible for it. And then we'll simplify it significantly. Okay, so the cervical plexus looks a little bit like this. So what we have here is we're looking at the ventral rami from cervical spinal nerve 1, C1, C2, C3, C4, and C5. And you can see how in each case those ventral rami don't come off and essentially remain, kind of independent. What they do is there's nerve fibers that join up together to form all sorts of different nerves that of course we give names to. So for instance, we see here that C1 has fibers that kind of come off and go in this direction. They join up with some of the fibers from C2. Also, it has some fibers that kind of come down here and join up with fibers from C2 and C3. C4 has fibers that join up with C3 and C5 and stuff like that. So you can see how it creates this net-like structure, right? Think of it like a really, really complicated roadmap, basically, is kind of what you've got. This is like the Southern California freeway system, right? I-15 comes into Southern California as one thing, and then I-5 comes in over here to the west of us as one thing, and then all of a sudden, when you get past either the Cajon Pass or over the Grapevine, kablooey, everything just kind of blows up into a whole wacky system of freeways, right? That's kind of how it works, right? That's kind of what we have here. So I didn't include this in my notes for a couple of reasons. One, you're not responsible for knowing every nerve that comes out of the cervical plexus. And the other is that I don't want to overwhelm you, at least not right away. We still haven't gotten to the brachial plexus. But you'll get through it, and by the end of the day, you'll be a master of it, I promise. But the point that I just wanted to make is that you can see that those nerve fibers kind of join and merge with others to form certain nerves. What I do have in my notes, let me go over to my notes really quickly. What I do have in my notes is I have sort of a drawing of the cervical plexus that I made. It looks kind of like this, which is the same general idea. I took this from your textbook, so it should look fairly similar. But again, you're not responsible for all of it. I just kind of wanted to show you how those nerve fibers are definitely kind of convoluted and form this net-like structure. The one nerve that we are kind of responsible for knowing, one of the more important nerves that come out of the cervical plexus, is a nerve called the phrenic nerve. Okay, the phrenic nerve innervates the diaphragm, and as you guys learned in 50A, the diaphragm is the skeletal muscle that essentially separates your thoracic cavity from your abdominal cavity, and it's the primary muscle that you use in breathing. Okay, the phrenic nerve innervates it, so as a result, it's a pretty important nerve for us to pay attention to, and it does arise from the cervical plexus. Specifically, there are nerve fibers that come from cervical spinal nerve 3, cervical spinal nerve 4, and cervical spinal nerve 5 that all contribute to the phrenic nerve. So one of the things that you might do someday is you might have to learn for all of these nerves. We're not going to do all of them. But you might have to learn which cervical spinal nerves contribute to those nerves. We're going to learn a number of nerves today, but we're not worried about which rami they come from. Except for this one. The way to remember this one is to remember that it goes C3, 4, and 5, keep the diaphragm alive, right? There's all sorts of great little memory devices like that for almost all of the major nerves in our body to help us remember where they come from. Okay? So the phrenic nerve, C3, 4, and 5, keep the diaphragm alive, right? We remember that. We know that it comes from the ventral rami of cervical spinal nerve 3, 4, and 5. Okay? Okay, so we're not going to do too much with the cervical plexus. Really, I just kind of wanted to show it to you. I wanted to show you that it exists and that we have the phrenic nerve there. I guess it's also kind of worth mentioning that there are a few fibers from cervical spinal nerve 1 that contribute to the hypoglossal nerve, which of course we learned about in our last unit as well. The hypoglossal nerve, because we learned about it in our last unit, you guys are aware, is considered to be a cranial nerve. But there are a couple of fibers that come from sort of the ventral ramus of cervical spinal nerve 1 in the hypoglossal nerve. As a result, there are some anatomists who argue that it's not technically a cranial nerve, but for time eternal, it's been a cranial nerve. I'm going to let the people who want to argue about that argue about it. Until they tell me it's different, I'm going to teach it as a cranial nerve. But there are just a couple of fibers that come from cervical spinal nerve 1 that contribute to the hypoglossal. Okay, so that's why we see it there. And apparently that one's a point of contention, but I've got bigger things to worry about, so I'm not too concerned about that. Are there any questions about the cervical plexus? Again, we're not going into really any real detail. You'll never be required to reproduce this on an exam or anything like that. Honestly, you'll probably never see the diagram again, but I might ask you, name the big nerve that comes from the cervical plexus. You'll tell me it's the phrenic nerve, okay, something like that. Okay. All right, anything? Okay, cool beans. Okay, so let me show you one diagram. I sort of skipped over it. I got ahead of myself really quickly. In the thoracic region, this is sort of what we see in terms of our structure. I'm backing up a little bit now, and I apologize for that. But this is our spinal nerve right here. And then you'll see that dorsal ramus kind of comes over here, and we can see that it's innervating that dorsal body wall. Some of those nerve fibers are going to the extensors of the back. Some of them are going to the cutaneous region. This is where we have a lot of touch receptors in our back and things like that. But then that ventral ramus here is simply going to the intercostal muscles that is forming that intercostal nerve that I was mentioning. Right? So there is no plexus in the thoracic region, which honestly makes our life a little bit easier. It's one less plexus that we have to learn about, right? So we have that. And this is the diagram that I had meant to show you as it related to this right here. I'm sorry I didn't pull that up earlier. There's no plexuses in the thoracic region. Okay. So we looked at the cervical plexus. Cervical plexus is fairly straightforward. Today in lab, we're going to spend probably a lot of our day on the brachial plexus. The brachial plexus is a little bit more complex than the cervical plexus, and we are going to learn most of the major nerves that come off of the brachial plexus. We're going to learn to identify them and things like that. So the brachial plexus arises from the ventral rami of C5 to T1. And I know I said that there's no plexuses in the thoracic region. There really aren't, but there are some nerve fibers from T1 that do contribute to this plexus. So, it's what I said was in the spirit of the law, not the letter of the law. That's typically the way that this, for instance, is the ventral ramus from C5. This is the ventral ramus from C6, ventral ramus from C7, ventral ramus from T8, ventral ramus from T1. In the context of the brachial plexus, we call those the roots of the brachial plexus. So we see here that there are 5 roots in the brachial plexus. You can see that like any good roadmap, things get somewhat complicated quickly. We see that for instance, we see that, first of all, there's a nerve that's kind of coming off here. We'll talk about that in lab today. There's also a nerve that's kind of coming off of here as well. But we see here that the majority of those fibers kind of join together right here. So the majority of fibers from C6 and C5 join together to form a structure that we call the superior trunk. Okay? We see the same thing down here, where the fibers from C8 and T1 also join together to form what we call the inferior trunk. C7 doesn't really do a whole lot. It kind of sticks by itself, and it forms what we call the middle trunk. Okay? So we see that once they join with something, we call them something else. And this is obviously for the purposes of just kind of keeping track of things, right? But those roots join together in different ways to form trunks. Okay? But then we see that they divide, all right? Those trunks are going to divide. So for instance, we see that the superior trunk divides right here. The middle trunk also divides, and then the inferior trunk divides as well. And we see that there's a lot of joining together of nerve fibers right here. These are what we call our divisions. So we have 2 divisions in the brachial plexus. We have the anterior division and we have the posterior division. This diagram doesn't really do it justice, but I think we probably can guess what's happening here, right? The anterior division is going to run down the front of the arm, and the posterior division is going to run down the back of the arm. One of the things that we're going to do today is we're actually going to put brachial plexuses on skeletons in lab, and we're going to see how these plexuses actually run. And I think putting it into sort of a 3-dimensional context will make this seem a lot easier. So what I'm saying right now is not meant to confuse you. We're going to go into this in a lot more detail in lab today, and like I said, by the time you leave lab, it should be really, really straightforward. And then finally, what we have is after our divisions, we have the chords. We have a lateral, a posterior, and a medial chord right here. And again, we'll take a look at that in lab today. So we can break down the major divisions, the major parts, I guess I should say, of the brachial plexus as the roots, the trunks, divisions, and chords. And if you need to remember how that goes, or the order in which they go in, you can remember really tired, drink coffee, right? If you remember that, you remember that it goes roots, trunks, divisions, chords, right? Really tired, drink coffee. And that will kind of help you to remember that. And then from there, what we're going to start doing is we're going to start naming individual nerves. We'll talk about that now. In your guys' lab manual, you guys have a very similar diagram to this, but it goes a little farther than this one goes by showing you the actual nerves. Probably a few of you guys have already started working ahead and started to name some of them and stuff like that. The diagram is straight from your textbook. It's pretty straightforward. In lab today, I'll put that up and we'll go ahead and start with that. It might feel a little bit overwhelming if you've already started that. You're like, how am I ever gonna learn this thing, right? That at least was my reaction the very first time that I saw it, when I taught it for the first time. I was like, how am I ever going to teach this? I think by putting it into a three-dimensional context and having your hands on something rather than just looking at a diagram will make this literally like 100 times easier, right? And so that's kind of the goal for lab today, is to put our hands on something to make this a lot easier. So the diagram that's in your lab manual, if you've already started working on it and you're overwhelmed by it, I can almost guarantee you that by the end of the day, it's going to be very easy for you to label those parts of it. If you haven't started it yet, by the end of the day, you should be able to knock out those parts by memory very, very easily. It's a very straightforward thing. It just takes a little bit of practice, and it takes a little bit of work to visualize it three-dimensionally. And then you're like, oh yeah, I totally get this, right? So that's kind of the goal for lab today, is to kind of go through that. But the nerves that innervate the arm, of course, can obviously be helpful. They allow us to move, but they can also be problematic as well. So for instance, one of the major nerves that we find in the brachial plexus is the ulnar nerve. Okay? The ulnar nerve, as you might have guessed, runs down the medial side of our arm. If I'm standing in anatomical position, it's running down the medial side of my arm, right next to my ulna, right? If you're keeping tabs, Christian, you can put a hashtag here. Anatomists are not entirely unreasonable people. The ulnar nerve is found right next to the ulna. So, cool. Okay, but what about it, right? Well, what it does is it runs from all the way up here, it runs down the arm. It actually pops right behind my elbow right here. It's mostly on the front of my arm, but when it goes around my elbow, it goes right behind the bones in my elbow. And at that point, my ulnar nerve is really, really exposed. Have you ever hit your ulnar nerve on something? Is it even remotely funny? No, it's not, right? It hurts, right? We call it our funny bone. But that ulnar nerve exposed right there is not funny at all. In fact, it hurts when you hit it on things, right? But that's one that we become really, really familiar with, is that ulnar nerve, which comes from the brachial plexus. Sometimes you might fall asleep on your arm. So the ulnar nerve does go down the ulnar side of your arm, and it innervates primarily these two fingers, your pinky finger and your ring finger. It doesn't innervate the rest of your hand, but it innervates the medial side of your hand right here. You've ever fallen asleep on your ulnar nerve and you've woken up with only half of your hand asleep? Like you can't feel those two fingers, but the rest of it is fine. That's because you fell asleep on your ulnar nerve and you put it to sleep, but not the rest. Another major nerve that comes from our brachial plexus is a nerve called the median nerve. The median nerve, as you might guess, runs down the middle of your arm, right? It goes straight down the middle of your arm, and it goes into your hand, really just right across your wrist. When it goes across your wrist, it's running across your carpal bones. Your carpal bones have a tendon that runs across them that creates a little opening or a tunnel that median nerve has to go right through. When that tendon becomes inflamed from poor posture or ergonomics or overuse or something like that, what it can do is it can compress the median nerve in the carpal area and cause carpal tunnel syndrome, right? Because it's passing right through that. Today, on the skeletons, you'll be able to put that median nerve where it belongs, and you'll actually see that little tunnel that's created in the carpals. The tendon isn't there, but you'll see the bony part of it anyway. And you can see where that carpal tunnel is going to be at, right? So these nerves come up a lot in all sorts of clinical situations, whether you accidentally hit your funny bone on something or whether you have compressed your median nerve and you're experiencing a lot of pain from a job or something like that, right? There's all sorts of ways that these sorts of things come up. So we want to take a look in lab, we want to take a look not only at the identification of these, but also, at least for some of the major nerves, we want to see how do we diagnose injuries to these nerves, right? Because that's also something that we're going to be doing, and it's something that is not terribly uncommon, right? So understanding this in a three-dimensional context is helpful. First of all, for naming the nerves, but also understanding where they go, right? Because if we understand where they go, that helps us to diagnose injuries to these nerves as well, Okay, so it's an important clinical thing for us to sort of pay attention to. All right. All right. So we're a couple of minutes early, but I feel like I've exhausted what I can talk about without something in front of me. So I'm going to shut up now and let you guys go a couple of minutes early. But I'll see you at 9:15.